Hi, there is Shenzhen Zmotion Technology Company Limited. Mainly for automation control area. There are motion controllers, network and PC-based motion control cards, vision motion controllers, expansion modules, and HMI. Here, Vision Motion Controller Learning Lesson 2. How to use together with the industrial camera. In last lesson, we have learnt some basic knowledge of machine vision. After that, it is time to start machine vision development. And the basic and important control object is industrial camera. Then, today, let's see Zmotion Vision Control first step. That is, how to use and control camera. Still, take the example of our Vision Motion Controller VPLC532E. VPLC532E is our Linux EtherCAT Vision Motion Controller. Specifically, it integrates machine vision, axis control, and I/O control. For axis control, it can be up to 32 axes. And there are many axis specifications for you. For this lesson series, its vision algorithm is mainly talked. Lesson 2, same, 3 parts for you. Part 1, learn industrial camera knowledge. Part 2, how to wire camera with VPLC532E. Part 3, how to capture graphic in our software RTSys. In this video, Part 1 and Part 2 are talked mainly. The operation will be shown in next video. Okay, let's see the Part 1 at first. Camera-related interface types, acquisition modes, and parameter configurations will be talked in this part. In Lesson 1, we have known some industrial camera types. Here, all kinds of interfaces will be shown. Because the interface determines output method and efficiency. According to interfaces, there are 4 normal cameras. USB camera, IEEE 1934 camera, CamLink camera, and JIGE Ethernet camera. Please see, they have own features. Generally, Giggle Ethernet cameras are used. Because it is low cost, high speed, and convenient wiring. And today, we also choose Vision JIGE Ethernet camera. After choosing suitable camera, how to wire camera and controller will be introduced in Part 2. Then, in software, there is one important function. That is, graphic acquisition. For this, there are 2 collecting modes. Free acquisition and trigger acquisition. Under trigger mode, you can select by hardware or by software. The corresponding RT-Basic command is set mode. RT-Basic is our own programming language in our IDE software RTSys. In RTSys, you can develop, debug, and diagnose program. You can download it from website and test it through simulator tool. And you can check former lesson about RTSys. Also, about the set mode usage and example in RTSys will be shown later. Let's continue acquisition modes learning. Free acquisition, it means it automatically captures the graphic in cycle after the camera starts. Set the mode parameter as -1 to enable free collection. But it is not recommended. Because the CPU occupy ratio is high, the utilization is low. Compared to free mode, trigger by software is better. Due to its low cup occupy ratio. Specifically, it captures 1 frame graphic after getting the command of mode 0. If by hardware, same as software, collecting 1 graphic when received trigger signal. But it needs hardware wiring. Set the mode as from 1 to N. Corresponding camera external wiring is from line 0 to line N1. Mainly for fly shooting. Then, if you want to get clear graphic, please set camera-related parameter. Like exposure value, gamma value, etc. And you can make low frame ration when in low speed occasions. In this way, it can reduce smear phenomenon. Next, these parameters are used usually. Firstly, enable the graphic acquisition frame rate by acquisition frame rate enable. Then, you can set corresponding frame rate by this parameter. And it can be set only when it is 1. Remain 2 are exposure time and brightness correction configurations. For exposure time, the timer longer, the brightness higher. But it also means it takes longer time on picture. In real application, make the light source's brightness larger, reduce exposure parameter. Then, the shooting efficiency can be promoted. This one is to do gamma correction for graphic pixel brightness. When it is set less than 1, brightness will be higher. And the value smaller, it will be higher. But if it is more than 1, it compresses the brightness. The value larger, the compression stronger. Okay, enter part 2. How to wire the camera, including wiring and Ethernet configuration. At first, we should learn what materials needed. For example, this HK Vision Area Scan industrial camera. Therefore, accept the camera. Please prepare the power adapter, 6-pin power cable, and the Ethernet cable. Then, it is easy if hardware trigger is not used. Please see this simple showing. Directly connect VPLC532, East Ethernet port LAN 2 to camera Ethernet by the cable. And connect camera itself power adapter poles and the 6-pin I/O power to VPLC532 EGND. Next, plug the power adapter into the socket. Now, they are connected. And corresponding LED will be on. Hardware wiring is completed. But if you select the trigger mode by hardware, you still need to connect camera IN to controller OP. Here, we connect controller out 0 to camera line 0. And this form shows its 6-pin definitions. According to above said wiring and hardware trigger wiring. Pin 1, 2, 5, 6 should be connected. Like this wiring reference. Pin 1 connects to camera 12 voltage power. Pin 2 connects to VPLC532E out 0. Pin 5 connects to controller power ground. Pin 6 connects to camera power ground. When they are wired as need. Next, configure them in software level. Generally, configure the camera IP in camera drive software. Because controller default IP are these. The unique requirement is to make them in same network segment, which means their IP's front 3 parts are the same. The last segment must be different. Now, LAN 2 is connected. Therefore, camera IP front 3 parts should be 192, 168, 1. The last one can be set as any value within allowable range. Here, we set it as 20. Please note don't make any IP same. After all these, it is time to program your project. Therefore, enter the third part, how to grab the graphic under different kinds of acquisition modes. Please see this process graphic. It shows how to do it step by step under free acquisition, hardware, and software trigger. It can be seen initial steps are the same. Scan the camera through checking their IP. When all cameras are found, please select needed camera ID. Then, you need to choose which acquisition mode is used. If you set the set mode as -1, free acquisition mode will be used. Next, it will collect the graphic and cycle when it received the continuous collection signal. And corresponding collected graphic is shown in HMI. Even if the graphic has been collected already, it is still collecting all the time. Except you press the button of Stop Collect. Then, the event ends. Okay, this is free mode. Under software and hardware trigger modes, please set the mode as corresponding values. Then, you only need to open the camera and send one trigger signal. One is software signal, another needs hardware signal. When it gets the trigger signal, one frame graphic will be collected and shown. Then, it ends directly. In next video, Zmotion will show you the steps of graphic acquisition under these modes. And show one example for you. Today's introduction is over. Thank you for your watching. And see you next time. About software programming.